the original function, natural log, x squared plus x plus 1, and second in table, I will plug in -1, -0.5, and 1. So I have, here I have 0, here I have -0.29, and here I have 1.1, roughly, approximately. Okay. At this point, I have to study the sign. So which piece of this derivative you are not going to waste your time with? That is guaranteed to be the denominator. It will never be 0. It's always positive, no matter what. So please plug in -1, and please plug in whatever 0 and tell me the sign of the derivative. On the left.
Negative.
Yes. And on the right? Positive. Okay, so now what should the function do here when its derivative is negative?
Increase.
Good. Is that true?
Yes. Yeah.
Perfect. What should the function do here?
Increase.
Is that true?
Yes.
Yes. Good. So again, I'm not graphing the function at all. I'm just presenting the y value so we can make a conclusion. So this,
question.
yes, please, please. Yes.
Can you go back to the
Yes.
So how did we find x equals to -half?
A fraction is 0 when the top is 0, 2x plus 1 is 0. I move 1 and divide by 2.
Okay.
Better?
Yeah.
Okay. So we have 0 here. We have -0.29 here. And we have 1.1 here. So now we are ready to identify each and every point that we studied. What is -1, 0?
Is that the absolute minimum?
It's this point. It's this point.
Nothing.
Very good. Now, -1/2, -0.29.
Is it both the relative and the absolute min?
Yes. And what about 1, 1.1?
That'll be maximum.
Yes, but absolute, not relative. I'm not saying you said that, but I just need to specify, we need to specify what it is. How do we feel about this? Do we need anything else or can we continue?
I have a question.
Yes.
What happens if the I don't know if it's a possibility, but if the function levels out into a horizontal line at some point?
Very good question. Excellent. So what happens if, and I think that this is your question, what happens if the function does this? You will have two absolute min.
What if it's just like it goes up and then starts going to the right and just levels off, staying to the right?
Like
so,
this?
Like if it just, yeah, like that.
If it's right in the middle, it's nothing. This will be the absolute max, this will be the absolute min, and this is also the relative max and absolute max, and this is the absolute min. So this is nothing. But if it does this, very good question. Then all these points are absolute max. And this is the absolute min.
So you could have more than one absolute max if it's a line like that?
Yes, you can have more than one absolute min. Yep. Very good question.
I know you said they're long, but can I please see one with a trig function just to go into?
Yes. Yes, let's take a look at the trig.
And then
And then after the trick, can we do one where the function is undefined? Where the f prime is undefined?
We have to find one. You mean for the on the closed interval?
Yeah.
On the closed interval, most probably will not be undefined. Once they give the interval, it's unlikely that it will be the function will be undefined on the given interval. Very unlikely. But if we are just looking to find, but we're going to have a lot of graphs in the next sections where we go through all the steps with all the first derivative, the function, and the second derivative, and functions will be undefined. So we're going to have plenty of situations like that. Do we still want to look at the trig function?
Please.
Okay, very good. So would you like to choose one and give me one?
Feel free to choose one that you have.
Okay. So I'm looking at f of theta, which is 2 cosine theta plus sine squared theta. And for this one, let's just find critical numbers. Find critical numbers, if any. Okay, perfect. So how do we start? What is our starting point? What do we need to determine first?
F prime of theta.
Very good. Can anyone help?
Is it -2 sine theta plus cosine squared theta? Or plus sine squared theta times, no, I'm lost.
How do we differentiate a function to a power?
Oh, it's 2 cosine theta.
Okay, let's go back. How do we differentiate f to the nth prime?
It's n f to the n minus 1.
Ah, times
Times f.
good.
No, times f to the n.
So 2
Cosine.
Sine theta?
yes, times
Cosine theta.
very good. So then we have f prime of theta is 0 because f prime of theta being undefined is not possible. Sine and cosine are defined everywhere. Good. In this case, I have to write it out. So -2 sine theta plus 2 sine theta cosine theta. What will be our first step for sure?
Factor out the sine.
Yes.
Sine.
I will divide both sides by 2, actually by -2, and get sine theta minus sine theta cosine theta equals 0. And yes, now I will factor sine theta, factor out sine theta, and what is left in parentheses? Remember, I start with 2 terms. I have to have 2 terms with minus in between.
So 1 minus cosine.
Very good. So now there are 2 possibilities. Can anyone give us those 2 possibilities? Trey and Killen, I haven't heard, I don't think, from you yet. Trey, are you with us?
I'm sorry, I'm not catching.
It's okay.
Theta 0.
Say it again.
Theta 0 or pi.
I have to write 2 options. What are the options for sine theta times 1 minus cosine theta equals 0? Before, you are way ahead. I just need to write the previous step.
Oh, and sine theta 0 and 1 minus.
Very
cosine.
good. Sine theta equals 0 and cosine theta equals
-1.
When I move cosine, it becomes positive.
I mean 1.
1. Very good. Now let's solve sine theta equals 0. Okay, Kilan, can you help us with sine theta equals 0? What are the options here? We measure sine on the y-axis. So which angles will have sine 0? Okay, at 0 and pi. So 0 plus 2 pi k and pi plus 2 pi k, where k equals 0 plus or minus 1 plus or minus 2 and so on and so forth. And what about cosine theta equals 1? Where is cosine 1?
Pi over 2 and 3 pi over 2.
Cosine 1 is only at 0 or 2 pi. But there is no need to write that again because it's already in here. So critical numbers. It doesn't say, let me see, let me check if it says, it says just find the critical numbers. It doesn't say whether we are looking at one complete rotation or all. So critical numbers will be theta equals 2 pi k, and the other one theta equals pi plus 2 pi k. We can condense those because 2 pi k will always be this, and pi plus 2 pi k will always be this. So we can just say pi plus pi k. We can condense these or just leave them alone. So these are the critical numbers. And what we just did was to solve a trigonometric equation. So we solved the trigonometric equation on this. So these are the critical numbers. We did not establish which critical numbers turn into max-min or not. So this problem only says, it only requires us to find critical numbers. If we want to find whether they are max-min, I will only look at 0 to 2 pi. And this is f prime of theta and f of theta. And we know that at 0, okay, at 0 and pi, 0, pi, and 2 pi, the first derivative is 0. We will have to plug in the original function to see what we get. At 0, this is 0, this is 1, so this will be 2. At pi, this is -1 and this is 0, so this will be -2. And at 2 pi is the same because this is 1 and this is 0. Now studying the sign of this is slightly more difficult. Okay, let's do that. So f prime of theta, I'm going to just factor out -2 sine and 1 minus cosine theta. See here, when I solve the equation, I can divide both sides by -2, but all factors have to stay in the derivative when I study the sign. So I'm going to plug in pi over 4 and 3 pi over 4. 3 pi over 4, 5 pi over 4. So I'm going to plug in pi over 4, or even pi over 2. It's even easier. Pi over 2 and 3 pi over 2. That's the easiest. Okay, when I plug in pi over 2, this is 0, and this is 1. So this will be negative. When I plug in 3 pi over 2, this will be negative, this will be 0. Negative, so this will be positive. So yes, it's decreasing, and yes, it's increasing. So this, if I'm looking at the closed interval 0 to 2 pi, I will say this is 2, This is -2, and this is 2. So we have an absolute max, they are the same value, and this is a relative and absolute min. So that's a typical situation for critical numbers for